we're going to talk about runtime security on Podman. And what I basically mean by that is what options are available out there in the community, in the open source world to secure your Podman containers. And so yeah, you want runtime security on Podman. So a little bit about myself. I am Rishabh. I work as a software engineer at Accuknox. I am a maintainer of Kubearmor. Kubearmor is a CNCF sandbox project. I am also an LFX mentor for Kubearmor. So yeah. So let's talk about what is Podman. Podman is a daemonless secure container engine that supports rootless containers, ships with Docker-compatible CLI. What that basically means is that you can basically do alias Docker equal to Podman, and you would not even notice the difference because they basically implements the same commands. But the important thing, in my opinion, is that it does not implement the CRI, which is the container runtime interface. And what that basically means is that you have all these CNCF tooling ecosystem, right? You have sandbox projects, you have incubating projects, you have graduated projects, but you can't use them with Podman because Podman actually does not run with Kubernetes, right? You can't use Podman as a runtime. So what is runtime security? Well, just to put it simply, it's like a bouncer for your container party, except this one reads system calls. But on a more technical note, runtime security refers to monitoring and controlling the behavior of your application during execution, especially when they are already running, right? Runtime security is all about runtime. And it basically enforces mandatory access control. So we're going to talk about runtime security on Podman, but from the lens of LSMs. And so the first one that we will talk about is selinux and how that basically works with Podman. So selinux, the most important thing about selinux is that it's one of the more mature LSMs in the Linux ecosystem. And it's a label-based enforcement system. What that basically means is that selinux does not care about your paths, your symlinks, or your files, right? It basically uses labels, and the labels sit on the inode of files, right? So that's why it does not respect all your Linux primitives. Well, selinux works on type enforcement. So in the first point, you can see that you have a container underscore t. This is what the type is, and this is selinux is a very fine-grained level of control on your application because you can see that there is a system user at the start. You have a system role, and that role has a type which is called container. Now, this is the actual thing that basically helps you enforce what your application should do or should not do, right? And that way, it's very fine-grained. And with the Podman containers, if you are learning using Arch or let's say Fedora Rail, I think they by default ships with selinux. And if you launch a Podman container there, this is what you will basically see, that they already have this label. So this is what actually a Podman container would look like when you run it with selinux. You can see that you are actually enforcing a label, which is the container runtime label. And then you have different type enforcements, right? For example, for the volume, you have, if you could notice, underscore capital Z at the end. That's basically that this is an exclusive mount. So only this container is allowed to have that mount, and other containers, if they try to use it, then they may mount it, but you can't actually access it, right? And so, yeah. And so you can see that the mounts are protected, but also if you see the HTTPD mount, you don't have a label underscore like a colon Z on it, but it's a different label on the HTTPD by default. And that's what actually separates selinux enforcement. So if you would have different labels on different things, and if the labels actually do not communicate with each other, meaning that they don't allow each other to access each other's resources, then they are by default denied. Well, selinux, it has its pros. And the first pro is that it's a type enforcement system, right? It's a very fine-grained level of control. It has MCS, MLS, right? So in the example, you can see that it has a severity and at a category level enforcement as well. So maybe you have the same type on two different applications, but maybe you have different severity, right? And you don't want them to talk to each other. So how can you have that very fine-grained level of control? You can have that to severity and category. It's a pure label-based enforcement system, so it does not respect path, symlinks, or mounts. So for example, let's say if you created a symlink of a file just to escape a selinux label, right? Then you can't access that symlink as well because it does not respect that. Well, there are cons as well, and this is the famous saying with selinux, one lifetime is not enough. But SELinux also lacks intra-container enforcement. And what that basically means is that you do have labels on containers, but what about binaries and files inside the container FS itself, right? SELinux does not have that capability to do that. There is also another LSM in the ecosystem, which is apparmor. Apparmor basically does profile-based enforcement, and what that basically means is that you now do not have any concept of labels. Your labels do not interact with the inodes of files or processes. You have a profile which is stored at etcd apparmor, which is the directory where all of the apparmor profiles are stored, and this is where you actually define the behavior of applications. So for example, you can see that the profile itself, right, it's denying etc shadow, for example. And if you run a Podman container with that profile, then you can see that if you try to access etc shadow, it will be a permission denied issue, right? So, well, apparmor, you could say that because SELinux, for example, comparing both of these, SELinux is label-based enforcement, and you would have to very deeply think about labels on each application, right? Each file. So if they are actually conflicting, then your application might not even start. But with apparmor, these are independent profiles. They do not interfere with each other. So you have that advantage of ease of usability, right? So it's non-intrusive. As I said, no, you could say, interference with inodes of files. So it's a purely profile-based system. Well, talking about pros of apparmor, it's a simple path-based access control, right? It's human readable. It's, in my opinion, it's easier than SELinux, at least in the learning curve. And it integrates with common distros such as Ubuntu or Debian, widely supported and actively maintained. So we talked about two LSMs, right? And we talked about how would you use them with Podman, the pros and cons. So what's remaining now? Well, we can see that we do have a complicated policy design with both of these, right? And we do not have runtime observability. What happens if a permission denied event happens? How do we get observability for that, right? And by default, both of these LSMs do have their audit systems at auditd and kernel log system. But in my opinion, these are a little hard to manage, but because these are general log statements, nothing very specific. And we do have a better way. Well, at the start, I talked about how you cannot use CNCF tools with Podman because Podman does not implement the CRI. Well, Kubearmor is a cloud-native project, and we are going to see how we can use this with Podman, even though Podman does not implement the CRI. Kubearmor is a cloud-native runtime enforcement system that restricts process behavior, execution of files, networking operations, and etc. Yeah. This is what Kubearmor design basically looks like. And so you have k8s, you have containers. These are Podman containers, right? Basically unorchestrated containers. Kubearmor also uses apparmor underneath, but it also uses a newer LSM called eBPF LSM. And we have eBPF for monitoring as well. So this is what Kubearmor in action would look like with Podman. So on the left-hand side, you can see that you have a Kubearmor policy. And you can start to understand that this is a very familiar thing, right? Because it's a YAML-based policy. Still, you are using it outside of k8s. So that's, in my opinion, what is very convenient. And also our policy design. You can see that we are blocking an action where a user, if they try to access apt or apt-cat, they get denied, right? And on the right side, you have our telemetry. So we have a CLI tool, which will basically help you trace any policy violations. And you get a very verbose and rich logging analysis, right? So this is what a zero trust policy would look like with Kubearmor. We have a very comprehensive policy design. What that basically means is that any of the use cases that you're trying to fulfill using process, file, or network, in my opinion, you can have a very comprehensive policy which will secure your Podman deployments. Well, this was a very short talk. Any questions? Yeah. Yeah. Kubearmor has support for SELinux underneath, but it's quite limited. In my opinion, I would rather have eBPF LSM or apparmor enabled on a system and use Kubearmor with that.
How does it detect those events that were validated in the policy?
So you're talking about Kubearmor, right?
Yes.
So Kubearmor has eBPF and it has LSMs. So they work in conjunction. And when you say tracking events, right? For example, I'll take example of EVF LSM. They are LSM hooks, right? LSM hooks are event-based. They are executed on event basis. What that basically means is that you can have a policy. Kubearmor keeps policies on eBPF maps, going a bit technical here, but they keep the policy in maps. And whenever an event occurs, you have the metadata with it in the hook operation, and the LSM hooks. And if you match the event, like the event metadata with your policy, if you have a match, then that means that this action or this event that is occurring is something to do with the policy. And if in the policy you can have an action, which you could say that it's allowed or blocked. If you block it, then the operation does not happen.
Okay, thank you.
Does it has anything of like observability where it automatically finds out, hey, these are the files or binaries I need to execute, then I observe it, then I'll create the profile? Because the biggest challenge or pain point for applications like Oracle, SAP SD is basically they have so many binaries and daemons and all. So it's very hard to do it in a manual process. So
well, our helper CLI, which is called Kubearmor, does have a command which is called Kubearmor recommend that can actually help you find, that will help you suggest policies for your workload. So you can run Kubearmor recommend on your Docker images or let's say your deployments, and it will suggest policies for you.
thank you.
Yeah.
Hey, hi, my name is Vinay. Let us say that I'm not on Podman, but I'm on an AKS or an EKS environment, because that's where my company usually deploy things. And if I want to use something like this there, does this interferes with that ecosystem, or I can directly add this Kubearmor or thing into my EKS? And how can I protect those Kubernetes nodes from talking to each other if I want to?
Well, first of all, Kubearmor natively supports EKS and AKS, but I'm not sure what you're trying to say when you say you don't want two nodes to talk to each other. Like, do you want to restrict what are you trying to restrict?
Like you just showed us in the Podman that okay, you can create some kind of policies in it.
Yep.
So can that be created in EKS and AKS, and that will not hinder with the Azure policies or EKS policies that we'll be having?
I'm not exactly sure what are Azure policies or EKS policies,
So,
but yeah.
Yeah. So with every CSP, you do get a policy that get defined to an EKS cluster. So you can attach a policy to that as well, right? Saying that, okay, this VM cannot be created here. Like the nodes are the VMs in the backend, right? So those are the top level policies that gets attached, and then that cannot be changed to certain things, and the things cannot communicate to each other or something like that.
Right.
They're private, they're public, blah, blah, blah. So if I want to create a policy with Kubearmor internal to my network, yeah, how would that entire flow looks like? That's what I wanted to understand.
Right. So, well, as I said, we natively support AKS or EKS, but regarding the policy ecosystem that you are talking about, we'll have to see if there are conflicting policies, right? But as with talking about just Kubearmor, it won't hinder your cluster operations. So let's say anything that is specific to AKS or EKS, we do not interfere that with, and you can just install Kubearmor, you can use a policy, and in my opinion, that should work. Okay.
Does Kubearmor also support blocking specific network activity in the sense that these are the only IPs the container should actually be able to connect to, for example?
Well, we do support protocol level enforcement,
okay,
but IP level enforcement we are not doing as of now. Protocol enforcement is something that we run.
Okay, thank you.
Okay. Yeah, we can, I'll be here around, we can connect afterwards. Okay, yeah, thank you folks.